1.9 is the limit as x goes to 3 of 3x squared plus 2x minus 7. So the first thing you're going to want to do when you see a limit, and it's like this, it's a normal limit, you want to plug it in. You want to plug in the value of x. This is the first thing you want to do. So this is going to be equal to the limit as, well, I guess we're plugging in 3, so we don't need to write that limit. So that's going to be equal to 3 times 3 squared, which is 9, plus 2 times 3 is 6, minus 7. That's going to be 27 minus 1, so you're going to get 26. And that's the limit for this. That's the answer for 1.9. It's as simple as just, plugging in the value of x. This is the best case scenario of a limit you could hope for, where it's just you plug it in and you get your limit and it's done, So hopefully you guys get lots of ones like that, although there probably will be some tricky ones, which I am going over. Three trickier ones in my opinion. 1.10 is the limits as x goes to 2 of 6 minus x to the 3/2 power. So again, the first thing we're going to want to do is plug it in. So we get the limit, or I guess I'm going to plug in 2, right? So 6 minus 2 is 4. So we get 4 to the 3/2 power. If you remember, this is the square root of 4 cubed, which is going to be 4 square root 4, which is going to be 4 times 2, which is 8. I mean, if you plug in your calculator 4 to the 3/2, it'll give you 8, but if for whatever reason you get a radical, yes? Someone have a question? If for whatever, do you need to explain it? Remember something to the 1/2 power?
I know.
We have x to the 1/2 power. That's equal to the square root of x.
5 o'clock, I thought.
Oh, now they come again.
I know.
No. If you write 4 to the 3/2 equals 8, you should be fine. But
it comes many times.
There probably will be a time in the class where you will get something to like the 3/2 or the 5/2 that's not going to be an even number. Like, for example, let me think of one. Let's think of the square root of 27, right? This is equal to 3 square root 3. But if you type in square root of 27 in your calculator, you're going to get a decimal, and you're not allowed to write decimals. So in this case, like in this one problem, it doesn't matter, but you do need to know how to do that. Right, no problem. Yeah, so you don't have to write that out, but it is important to know. That's the only reason why I did it that way. Any questions on that one? Can you explain where the 4 came from? So I plugged in 2 for the limit. So this is equal to 6 minus 2 to the 3/2. 6 minus 2 is 4, so it becomes 4 to the 3/2. For 1.12 is the limit as x goes to 4 of, this is a big one, but it's not too scary, don't worry. It's gonna look a little scary, but it's the square root of x squared plus 9 minus the square roots of x plus 21 over x squared minus x minus 12. Now, if you're looking at this and you're like, oh my god, what do I do? The denominator equals 0. At the beginning of the session, I mentioned pages 67 to 69 in the textbook have 3 examples that are really good. For if the denominator is 0, I would recommend looking over them, but we are going to go over one of the things that's one of the techniques that they use in one of those examples in this problem. So you see, if we plug in 4 here, which is the first thing we're going to want to do, we end up getting a 0 in the denominator, right? 4 squared is 16, minus 4 is 12, 12 minus 12 is 0, which is indeterminate. You're not supposed to be able to have that. You can't divide by 0. So what we're going to do is we're going to multiply by its conjugate, and all a conjugate, or the conjugate of the top, the numerator. So, wait, what happened? Oh, so basically the first thing you want to do when you see a limit is you plug in the number right there. It's the first thing you want to try every time. We plug in 4, we get 6, on the denominator, we get 16 minus 4 minus 12, which equals 12 minus 12, which equals 0. You can't divide by 0, so we have to do something else before we can evaluate this limit. You have to algebraically manipulate it.
You said plug in on the denominator?
Yeah, sorry, I know I highlighted the top, but that's because where I was going with conjugates.
Confused.
Yeah.
Okay.
Well, you just plug it in general. You plug it in everywhere, but I'm just mentioning the denominator because the denominator ends up being 0, and we're not allowed to have that.
Okay, gotcha. Thank you.
No problem. So yeah, because the denominator is 0, we have to algebraically manipulate this before we can go ahead. Yes, you can factor, Devin. That is one of the techniques, and that's actually the first thing I tried when I saw this problem. But unfortunately, you still get 0 in the denominator. You can't factor out anything in the numerator, so you're still stuck with where you started, unfortunately. But that's a good thought. I think we are going to use that technique on the next problem. So a conjugate of something, we're going to multiply by the conjugate of the numerator. So the conjugate of the numerator, so I'm just going to go ahead and rewrite this part right here. The conjugate of the numerator is just, that minus sign is going to become a plus sign. And then we're going to multiply that over itself. So we have this whole thing. I'm going to write that in parentheses. X squared minus x minus 12. We're going to multiply by the numerator's conjugate, which is going to be the square root of x squared plus 9 plus the square root of x plus 21 over the same thing. So over x squared plus 9 plus the square root of x plus 21. We're allowed to do this because we're essentially multiplying by 1, right? Something divided by itself is always going to be 1. So that's why we're allowed to do this. So multiplying that through, there is a property. I mean, you can go ahead and multiply it through if that's what you want. But for conjugates, if you're multiplying a plus b times a minus b, which is what we're doing right here, that's always going to equal a squared minus b squared. So knowing that, I'll move this somewhere else. I don't want to erase it in case someone needs that. So that's what we're going to use. So we want the denominator to not equal 0. So we could multiply it by the denominator, but I don't know if that would really get us anywhere or get us where we want to get. Usually you want to multiply by stuff in the numerator. We want to get rid of those square roots as well. So that's why. And we want to see if after we multiply by the conjugate if we can cancel stuff out. So we can get our denominator to not equal 0. Okay. So from here, using that property I set up there, I don't want to explain it out just because that'd be a mouthful. So this is our a right here, our x squared plus 9. So we're gonna get this.
This is so hard.
I'm so sorry. Hopefully you can come to my session on Thursday. We're gonna be doing the same thing, just different problems. But yeah, don't worry, you guys will get the hang of this, I promise. So it's going to be x squared plus 9, the square root of that squared, minus the square root of x plus 21 squared, over x squared minus x minus 12 times square root of x squared plus 9 plus the square root of x plus 21. So now simplifying this, we're going to get the limit as x goes to 4 of x squared plus 9 minus x plus 21 minus x minus 21, right? Because that negative is going to distribute over x squared minus x minus 12 times the square root of x squared plus 9 plus the square root of x plus 21. Now, if we simplify that numerator, negative 21 plus 9 is equal to 12. So in this numerator, we really have, shouldn't have done that. We really have x squared minus x minus 12. And now we can cancel stuff out, right? We can cancel out that x squared minus x minus 12 over x squared minus x minus 12. So now we're just left with the limits as x goes to 4 of the square root, or 1 over the square roots of...
I'm having a little trouble keeping up. Sorry.
Are you good? All I did was that numerator. I'm going to write this in green. I just rewrote that as... So initially it was x squared, so... Hold on, let me... So for here and here, the square of the square root is just what's on the inside, right? So I was left with x squared plus 9. X squared plus 9 minus x, because there's that minus sign right here, minus x minus 21. So that green part is going to be equal to x squared minus x. Negative 21 plus 9 is equal to negative 12. Is that what you were struggling to keep up with, or do I need to go back a little further?
No, I'm good. I'm good now. Thank you.
So if they weren't able
Oh, Tommy's saying otherwise.
So from... 1.7. I'm not doing 1.17 today. I'm doing 1.17 on Thursday, Dawson. If you can't come to that session, please send me like a DM on group me, and I will work with you if you can't come on Thursday. So further back, Tommy. So recapping, initially I plugged in x equals 4 in our limits. We got our denominator as 0. So we had to do some algebraic techniques to help us with that. One of those algebraic techniques is multiplying by the conjugates of either your numerator or denominator. In this case, we want to multiply by the conjugate of our numerator because it has these nasty square roots and we kind of want to get rid of those a little bit. All the conjugate means is you're multiplying by the same thing, but it has a different sign in the middle. So if you see I'm multiplying by the conjugate with the plus in the middle, and that over itself, because we want to make sure that the function still stays the same. We're basically multiplying by 1, but with the conjugate of the numerator over itself. So after multiplying by that through, we end up with this right here. So we have the square roots squared on the numerator, and then we have our initial denominator multiplied by the conjugate. After simplifying some, we see that our numerator is actually equal to x squared minus x minus 12, which is something that's in our denominator. If you have two things that are being multiplied in the denominator over the same thing in the numerator, you can cancel those things out. So now we're at a point where we're left with 1 over x squared plus 9 plus the square root of x plus 21. Alright, Grant. I hope this I'll go a little longer because I do want to finish today. I think I only have I think I have 3 more problems, but if you want to stay, you're welcome to. Please sign in if you're gonna leave now. I really appreciate it. It really does help me out.
I signed in, but yeah, I do have to go now. I wish that you could post some kind of recording of the last few minutes, even.
Yeah, I'm just not allowed to. Like, honestly,
yeah, no, I understand.
If for whatever reason, I didn't say this, but if you have your audio like coming out of your computer and you record it with your phone, like no one's gonna know. So if you want to do that, you're more than welcome to. I don't care, but just you didn't hear that from me.
But we'll continue. Like we'll have a continuation of this on Thursday.
Yes.
And even going over what we already went over as well.
Yes. I mean, we're basically doing the same types of problems on Thursday, but with slightly different numbers, different functions.
All right. Well, thank you so much. You have a good night, y'all.
No problem. Hope good night. Yeah, no problem, Nick. See you Thursday. Can you explain how you got the numerator x squared plus 9 squared? That isn't my numerator, Tommy. The numerator is x squared minus x minus 12. The top one where it's the square root of x squared plus 9 squared. The whole thing is squared. So when you're multiplying by a conjugate, there's this rule that I have written right here. It's a plus b multiplied by a minus b is always going to be equal to a squared minus b squared. Yeah. How do you get after that? So the square of a square root is going to cancel each other out. They're opposites of each other. You know how I said earlier that x the 1/2 is equal to the square root of x. If you want to rewrite the square root of x as x the 1/2, so if you have x the 1/2 and that whole thing is squared, that's equal to x 2 over 2, which is just equal to x. If you weren't able to cancel out, would you plug in as is? If you weren't able to cancel out, you would plug it in, see where you're at, and if you didn't get anywhere, I would go back to the original problem and try a different strategy. Yeah, no problem. Did that help? Do you FOIL it? Yeah, you do. Or are you talking about the a plus b times a minus b up at the top? You don't FOIL it because they're just opposites of each